What is going on, guys? I'm back with another video, and in this video we are now going to be transitioning to linear combinations and figuring out if a vector is a linear combination of another vector or two or three. There could be an infinite many number of vectors, but in this example that's where we're going to find out how we're going to do it. So in this example, it is asking us to determine if the following vectors are a linear combination of the two vectors. So in our first vector v1 is 1, negative 1, 2, and then our second vector would be 2, 0, 3. And so our first vector that we have to check is 4, 1, 3. So what this is essentially saying is, can I find an A and B that are what are they, real numbers? Real numbers? Real numbers? Yeah. Real numbers such that A times V1 plus B times V2, it is equal to, just gonna make this equal to V3. V3. And so this can pretty much be kind of like a system of equation type of question. And so what we can do is we can put vectors v1 and v2 and then this vector or v3 into an augmented matrix. And so we're just going to go ahead and do that right now. So we're going to start off with v1, 1, 2, 2, 0, 3, and then 4, 1, 3. And so now what we have to do is we can put in row reduced echelon form, but row echelon form or reduced echelon form should also do the trick. And so we're now so that's what we're gonna pretty much be doing, and then checking if the answer that we get will tell us if it's a linear combination or not. So let's just go ahead and start off with subtracting, or not subtracting, adding row 1 and 2 together. So we get a new row 2 and also get rid of that 1. Row 1. And so we're just going to get 1, 2, 4, 0, 2. It's 4 plus 1. 5. And the bottom one stays the same. And now we can get rid of this 2 simply by adding twice, or negative twice, our 1. And so now the first two rows stay the same. 1, 2, 4, and 0, 2, 5. Then this would be 0, and this would be 2 times 2 is 4, which is negative 4 plus 3 equals negative 1. And then we have negative 8 plus 3, which would be, that is a terrible line. 3 minus 8 is negative 5. All right. So what we can do now is we can get rid of this 1 simply by adding half of the second row. And you should be getting 1, 2, 4 stays the same. This stays the same. Now this would be 0, be 0. This would be negative 5 halves. Now that we have this in reduced echelon form, we can now see if this can be a linear combination of the other two. And and we can notice that this portion we might have a bit of a problem here, because if you would have just multiplied our constant a by 0, then add b times 0, and you want it equal to -5/2, well, the entire left side would just be 0, but that is not equal to -5/2. So that means that our third vector, so our v3, is linearly independent from v1 and v2. Therefore, it's not a linear combination of v1 and v2, because if you remember from the lecture, if a vector is a linear combination of a set of vectors, then that vector itself is linearly dependent. So that means the opposite will be true. If it's linearly independent, then that means it cannot be expressed as a linear combination of a set of vectors. The only exception is if you just let some constant a, b, all the way to as many letters equal to 0, and so in this case it's not going to hold true that we have our third vector being a linear combination of the other two. So now we can go ahead and move on to the second part. So now we're given 8, -2, and 13. And again, it's the same process. We want to know if there's an a multiplied by 1, -1, 2 plus b 2, 0, 3 is equal to, is it 8, -2, 13. So we're just going to put this in row reduced echelon form, -1, 2, or row echelon form, whichever you want to do, depending on how much work you want to do. And so again, same process, cancel out the ones. So we're just going to get 1, 0, 2, 2, 2. This looks like a 6, bro. 2, 2, 3, 4, 5, 3. And then cancel out that 2 at the bottom left. 0, 0, 2, 2, 4, 5. And so now we have 2, -1, then -5. Okay. Oh, oh wow, I messed up badly. Okay, interesting. I don't know where I got these numbers, or why am I still on the last example actually. Whoops. Okay, start all over. 8, -2, 13. Cancel out the ones, so you just add them together. So 8 minus 6, 13. Then we have, what did I do here? Oh, cancel out the 2. So this would be 8, 6, and so I multiplied it by 2. This would be -3. Yes, -3. And so now we can cancel out this -1 by multiplying it by twice the second one. So we have 1, 0, 0, 2, 2, 8, 6. This would be 0, 8, 6, and then 0. And now we pretty much have this in reduced echelon form. And so now, do we have it in reduced echelon form? Yes, we do. And so now we can see that we have a row of zeros. And so actually I think it's better to have this in row reduced echelon form. because we can see some other things. Okay, so let me actually do this real quick. 1, 0, 0. Well, zeros stay the same. And then this would be 2, 6. And then this would be 0. So negative, negative, negative. 8 minus this would be 2. Okay, cool beans. So yeah, we have a row of zeros, and so what that means is we are going to have a linear combination of on the fourth vector, I guess, vector. This is gonna be vector B. Vector B. So what that means is that there exists an A and B such that AV1 plus BV2 is equal to V of B, since we have a row of zeros, and then also our pivots. So our number of pivots, that's another thing you can look at. The number of pivots is equal to the number of what is it? I mean, yeah, vectors given, as in we were given v1 and v2, and then we had to check if vb is also. So the number of pivots is equal to the number of vectors given. So that means that we can find a scalar, or two scalars for v1 and v2 to equal to vb. So that means this v of b is a linear combination, since it's linearly dependent. And so if you want to find the scalars, then you just pretty much have to put this back in row reduce, or all the way down in row reduced echelon form. So this would be 1, 0, 2. This would be 3, 0. And so that means, what is it? A should equal 2, B should equal, what? Can't read. 3. And then we can double check if 2 times 1, negative 1, 2, plus 3 times 2, 0, 3. That will give us 2, negative 2, 4, plus 6, 0, 9. And that'll be 2 plus 6, 8. Negative 2 plus 0, negative 2, and then 4 plus 9 is 13. And we can see that is also equal to V of B. So yeah, we just confirmed that this is a linear combination, and we also, or I just also showed y'all how to check if a vector is a linear combination. So what you pretty much do is put it in augmented matrix, and then you have to put it in, or you could do it in reduced echelon form. Yeah, you could do it in reduced echelon form. And so once when you do that, you have to check if the number of pivots is equal to our vectors that are given. And if the number of pivots is equal to the number of columns, then that means they're linearly independent from each other. So yeah, that's another thing to note. So if number of pivots is equal to number of columns, then v, or vectors, are linearly independent. And we can see on the first example we have one pivot, two pivot, three pivots. So we have 3 pivots and 3 columns. So yeah, that's pretty much it, and we're just gonna work on one more example on the next video. So I'll see you guys in the next video.